Today we're looking at conditional probability. It's when we have a condition of something that we want to happen before we look at a probability of an event. So let's dive right into how we find such things. So if we want the event A, the probability of it, given that event B has already happened, so this is conditional probability, we can write it as A in a little line, B like so. And to find it, what we need to do is find the probability of A intersection B divided by the probability of B. So whatever this letter is here goes to the bottom, intersection of the two goes to the top. So let's look at this example here. We have 200 students, 42 study French only, 25 study German only, and 8 study both. For a problem like this, it's really nice to put this information into a Venn diagram, which really takes almost no time to set up. You're just drawing a couple of circles and then put the information in. So we've got 42 doing French only, 25 doing German only, and 8 doing both. So whatever is left, because out of 200 students, will be going to the outside space. So like this is what we have. And we're looking for the probability of someone that studies French given that they study German. So we're looking for probability of someone studying French given that they study German. That's what we're looking for. So to find this, we need the probability of F intersection G over probability of G. So as you can see, probability of F intersection B is the 8. It's the 8 out of 200. And we're dividing this with, so I'm just write divide because we have two fractions. So that's the first bit here, and this is the divide bit. So we're dividing it by the probability of G. So G, there's 33. So be careful, you're not only looking at the 25, but also looking at the 8. That's all part of G. So it's 33 out of 200. So two fractions. So you can change, flip, and do keep, change, flip. Calculate the fraction. So it's going to be 8 out of 33. And I could do that quickly because I can cross cancel. Remember, your fractions, you can cross cancel if you are timesing them and there's some common factors between them. So the probability of French given German is 8 over 33. Alright, let's jump into another example here. So we're just picking up some marbles out of a bowl. They are either blue or black, and some of them are marked A on it and some of them are marked B on it, and this is a two-way table to show all of that information. We're finding the probability that when we randomly pick something out, it is marked A. So this is out of, if we add all of these up, we get 112. So that's out of 112 marbles. So, and the ones that are marked A are these two. So it's going to be 77 over 112, which is 11 over 16. Actually, it will be over here. Might need a bit more space because it is a conditional probability because we got given here. So we got marked A given that it is blue. So let's write marked A given that it's blue. So to do this, we need the probability of A intersection blue over probability of blue. So to do that, running out of space here, gotta be conscious of the space. To do that, we want A intersection blue, so marked A is here, blue is here, so where they intersect is this bit here. So we got 27 out of how many? This many, divided by probability of being blue, which is just these two here, and that's 40. So when we do this, we are going to get 13 over 35. That is incorrect. We will get 27 over 40. Alright, part C, it is a blue marble. That's an easy one. So it's just probability of blue. Like we said, that's 40 over 112. So it's going to be 5 over 14. Alright, last question, we'll fit it in here. Is probability of blue given that it is marked B. So just set up the equation. So you need the intersection of blue and B over probability of B. So the intersection of blue and marked B, so blue is here, marked B is here, intersection is this 13 over here. So it's 13 over 112 divided by probability of marked B, which is this bit here. That is up to 35. And then altogether it becomes 13 over 35. Alright, next question. We're given almost no context, but we're given a bunch of different probability, and we're asked to find A given B and B given A. So this is just a matter of knowing what to use. So I'll just set this up. Probability of A given B is going to be probability of A intersection B over probability of B, and I'll set this one up as well. So this is probability of B intersection A, or A intersection B, the same thing, over probability of A. Now obviously the key thing, we need the intersection between A and B in both of the equations. However, we're not given that, we're given these three. But that's actually enough information for us to find what we're looking for, because we know the union of A and B is probability of A plus probability of B, take away probability of A intersection B. So if this is 0.6, this is 0.4, we don't know A intersection B. However, we do know the union, which is 0.8. So we can actually find the probability of A intersection B just by rearranging this, and it should be that's up to 1, 0.2. So now it's a lot easier to answer these questions. So this first one, we have the intersection 0.2 over probability of B that's given to us in the question. So this is just half. And this next one as well, again 0.2 is the intersection. Probability of A is given to us, so it's just going to be 1/3.